All right, good afternoon, 8th grade class. Glad to hear you. This is Mr. Hale. Just want to start doing some video lessons for you. And our first lesson is going to be our next chapter, Chapter 14, which is dealing with thermodynamics and heat transfer. And today's lesson is about 14-1, temperature and thermal energy. So first, let's understand what temperature really is. Temperature, the definition, is the measure of average kinetic energy. Molecules move. Remember, moving molecules means they have kinetic energy. The more energy you have, the more temperature you have. Molecules bouncing around. The hotter something is, the faster that kinetic energy goes. Temperature is defined as a degree of hotness or coldness as measured on a definite scale. Now, let's talk really quick about total energy, thermal energy versus temperature. Temperature is the average, is that average kinetic energy. Total energy, talks about all the energy combined. So when you're talking about total energy, think which one has more energy? An iceberg or a cup of hot coffee? An iceberg actually has more energy than a cup of hot coffee. Hot coffee, although each molecule is moving around really, really fast, there's just not many molecules, whereas an iceberg could be the size of Rhode Island. Molecules are moving slow, but there are just so many of them. So an iceberg has more total energy than a cup of hot coffee. You can also think of it, would you much rather me give you in our classroom the $200 bills or the entire room filled up with pennies? You know, some people are going to sit there and say the $100 because they don't want to deal with the pennies, but there's a lot more money going to be made if you take the pennies, because even though there's not many the penny's not worth a lot, since there's so many of them, they create more total energy. Now, temperature scales. How do we actually measure this average temperature? So we have three types of temperature scales we're going to look, or four types of temperature scales you're going to look at. We're really going to really focus on three. You're going to know about the fourth, but only really focus on three. Let's first look at the Celsius scale. In the Celsius scale, they take the freezing and boiling points of water. Okay, look to the right, you have the freezing and boiling points of water. And in the Celsius scale, they said, let's put 100 degrees between the freezing and boiling points of water. So they basically took a thermometer, put it there, and they measured the freezing and boiling points of water, put hash marks, and then they took those between the first and the last and put 100 degrees between them. Okay, that is the, give me a second, turn my internet off. That is the freezing and boiling points of water. That is Celsius. Very accurate scale, very well used. Okay, now let's look at the Fahrenheit scale. The Fahrenheit scale, was developed to work with the medical fields. What the Fahrenheit guy wanted to do was say, instead of having 100 degrees as the boiling point of water, let's make 100 degrees as the average body temperature. That way a doctor will know if you are running a fever or not. If you're above 100, you're running a fever. If you're below 100, you're not. The scale was screwed up, but that's what they tried to do. So he wanted to take a very accurate scale, make 180 degrees. He took 180 degrees and said, let's put that between the boiling and freezing points of water. If you look between 212 and 32, there's 180 degrees. And he said, let's put that, and he tried to adjust the scale so it would be 100 degrees as the human body temperature. He screwed up. Don't know what happened, screwed up, never fixed it. So our average body temperature is actually not 100 degrees, but 98.6 degrees Fahrenheit. So those are the two major scales. Now, the other two scales are based off of the Fahrenheit and Celsius scale. The Kelvin scale is very much like the Celsius, but look at the Kelvin scale. There's 100 degrees between the boiling and freezing points of water. Same thing as Celsius, but the Kelvin says, I don't want any negative numbers. I'm going to go to the absolute coldest temperature possible. Okay, the coldest thing you could possibly get, Mr. Hale's heart, the coldest thing you could possibly get. And we're going to start with our scale there, so we can never have a negative number. Other than that, we're going to use a Celsius scale. The other one, called the Rankine scale, that's the same with the Fahrenheit. It has 180 degrees between the freezing and boiling points of water. Okay, but it has no negative numbers also. because temperature is more of a scale. It doesn't really have a negative, so they want to get rid of those. You're probably never going to see the Rankine scale unless you're from Ohio University and some little leprechaun Irish professor who just told us we had to learn it, which I had to. Then you're probably never going to see that scale again, but just so you know, it is there. Now, here's some more points. You can stop this if you want to read a little bit more about the temperature scales. Don't worry about the International Temperature Scale. But if you want, pause it here. You can write down some more notes if you want to see some more notes on that. Biggest thing is, Fahrenheit was based off the human body. Celsius is based off of the freezing and boiling points of water. Now, what is absolute zero as we finish out our lesson? Absolute zero is the lowest possible temperature where nothing can be colder. Remember, temperature is the measure of how the molecules are moving. Less temperature and molecules are moving slower. There is a point where the molecules don't move anymore. When the molecules aren't moving, you've reached absolute zero. Okay? You can't get colder than not moving. Thus, it is a set number. For Fahrenheit, it is negative 459.67, and for Celsius, it's negative 273.15. You will not have to know those numbers. Just, that's how cold we can go. We can't go any colder than those two numbers. We've gotten really, really close, but we've never gotten to that number, nor can we, as theoretically it's impossible off our current ideas of physics and chemistry. So, those are scales, temperature scales, and absolute zero. That's our lesson for right now. This is KD2LPM for K2GSG, and we're signing out. See you next time.